Hi, this is Sean Dustin, the Market Manager at Campbell Scientific for the Structural, Industrial, and Geotechnical Group. Today what we're going to do is go through a quick demonstration for viewing the data from the Dynamic Vibrating Wire Analyzer. And so here we have the yellow box demo, and we're going to go ahead and tell that to run. And we will delete all the data because we want to run a new program here. So now we're waiting for that to start, and it says it's fine. So now it's running, and we're going to view the data. So to do that, we're going to use the monitor data and graph, and we will use a real-time graph number 1, which is the one we've just been working with. Now, you'll notice that the vibrating wire strains and the foil strains are not in line with each other. So up here you can see the vibrating wire, and then down below here's our bonded foil and our bonded foil. What we would like to do is we'd like to compare those two simultaneously. So in order to do that, we are going to use the calibration wizard, which is part of the software package, and we've got it set up, so we'll go ahead and hit calibrate. And as soon as these scroll over, then the screen will reset. You can see that data scrolling across. And now it's reset. And as you can see, the data in blue is the dynamic vibrating wire data, while the data in red is this traditional bonded foil strain gauge data. And what we see from this is we see that the noise from the bonded foil gauges ranges from 0, well, starting from 0, we're going from 0 to as high as 0.34 microstrain. The range is approximately negative 0.3 to positive 0.3 microstrain. The range on the vibrating wire data is approximately negative 0.02 to positive 0.04 microstrain, so about an order of magnitude less on the noise. We're going to go ahead and calibrate again to just bring everything back to 0. Neither of these gauge sets are temperature compensated, and the temperature in this room is varying quite a bit, so they do have a tendency to drift. Alright, so we've reset the calibration, and now I'm going to just demonstrate the behavior of the system by manipulating the end of the beam. So just a light touch on the beam, and you can see the oscillation in strain from that tapping. Now if I put something on there with a known mass, like for example this computer mouse, and there's the data from that load and subsequent impact on the desk. It's sensitive enough that tapping the desk will also produce a load in the beam. Alright, so I'm going to go ahead and stop the video now. We'll save this data set, and we should be able to tie it into these different loading scenarios. that we have as well. And please again keep in mind that the reason for the drift is that neither the vibrating wire gauges nor the bonded foil gauges are thermally compensated. And there we see the drift, especially on the yeah, it looks like all of them are tending in a positive direction. So, all right, that's it for the video.